Good afternoon, everybody. Welcome to Tuesday afternoon of Chem 1105 with your host, me, Dr. White. Hi, everybody. Give me a second. I'm running about 30 seconds late. Oh, no, he's late. I'm logging into Blackboard now. All right, let's get going. All right, first of all, let me remind you again, this Thursday at 8 a.m. or maybe even a little earlier, I will send out the password for the final exam PDF file. You will have until Friday, 2 p.m. to finish and upload your answers to the final exam. I've been pretty lenient this semester. However, this has to be a firm 2 p.m. deadline. Again, you will have until Friday, 2 p.m. to upload your answers to the final exam. If it's after that, I'm going to give you a 0 for the final. I'll say that again. You have until Friday, 2 p.m. to upload your answers for the final exam. If it's after 2 p.m., I reserve the right to give you a 0 for the final exam. So please don't miss the deadline. All right, the final exam will have 27 problems, 8 pages. Some of them are multiple part. There are 5 multiple choice. Point breakdown. Material on test 1 will be 16 points. Material test 2, 44. Material test 3, 29. Material test 4, 21. And please read the rest of this. And like I said, instead of 50 points, I reserve the right to give you a 0 if you don't upload your answers on time. Also, on this Thursday, there will be no Zoom meeting. Next, I'd like to remind you, the deadline for all labs is tonight, 11:55 p.m. At that time, all labs that have not been submitted will be given a 0 score. Also tonight, 11:55 p.m. is the deadline for the optional extra credit project. Now, this morning, part of this afternoon, all labs that were handed in as of this morning, 8 or 9 a.m., I have graded, and after class today, by about 7 p.m., 8 p.m. maybe, I will upload the answers, not the answers, not the answer. I will upload your scores for any late labs that you've handed in as of 9 a.m. this morning. And that will also include the extra credit project. All right, any questions? I can hear better this way. Actually, the speaker's up there. All right, well, let's get back to work. I'm glad one of my students is good. All of you should be good, and I hope you are. All right. They've done something new on Zoom that when I shut something down, sometimes it opens up a window, and that's why I'm looking over here. How do I close it? All right, let's get back to work. Yesterday, I was going through test number 2 review. And let's talk about the mole. What is the mole? the mole is the chemist counting unit. Now, there's a couple ways of defining a mole. A mole is of an element is equal to Avogadro's number, 6.02 times 10 to the 23rd atoms of that element. 1 mole of a compound is equal to 6.02 times 10 to the 23rd molecules of that compound. 1 mole of an element equals the atomic weight of that element in grams. 1 mole of a compound equals the molecular weight of that compound in grams, and the molecular weight is the sum of all atomic weights. This will be given to you, important information, the final exam, as you see on your screen right there. Now, remember, I gave an on test on the final exam, besides saying, please use proper significant figures for all calculated answers, it will now also say, like it's done for test 2, 3, and 4, please use 3 significant figures for all atomic weights. Now, let's look at a couple of problems. Adjust my pad. That's why I'm not writing straight across the screen like I normally do. Let me adjust it. All right, let's look at this problem. How many moles of HCl are 1.333 times 10 to the 43rd molecule of HCl? All right, we're going to do this stepwise. First step, I'm asking you, what are you being asked to find? What are you given? All right, what are we asked to find? How many moles HCl? What are we given? How many molecules of HCl? And now, the only thing we have to start with is this, and I will. And we had a ratio that we could convert it. The units we want our answer are moles of HCl, because we took the time right here to figure that out. Now, your turn again. What units go on top and bottom of that ratio? Your turn. Remember to use your good buddy, your good friend, unit analysis. All right, so what do? We use our good buddy, our good friend, unit analysis. Whatever units we're trying to get to, go on top of the ratio. Whatever units we're trying to get rid of, go underneath. So now I'll write them in. And where do we get these numbers? Well, you can look at important information, final exam, 1 mole of a compound equals Avogadro's number, 6.02 times 10 to the 23rd molecules. And that's where you get the numbers. So for every 1 mole, there's 6.02 times 10 to the 23rd molecules. Notice molecules divided by molecules cancel out because anything divided by itself equals the number 1. And now I can happily pick up my calculator, turn it on, clear it. I have 1.333 blue double E 43 divided by 6.02 blue double E 23. And my calculator gives me this answer. Now, remember, you get the same number of significant figures in your answer in a multiplication division as the number with the fewest significant figures. And this has all non-zero numbers are significant for significant figures. This is an exact number that plays no role in determining significant figures. This has, 2 non-zero numbers, but there's a 0 after the decimal and also between 2 non-zero numbers. So that's significant. There's 3 significant figures. So you need to round this off to how many significant figures? Well, what's the lowest number? 4 or 3? And time's up. It's 3. I'll give you 3 seconds to round this off to 3 significant figures. I'll give you a few more. Time's up. Keep the 2, keep the 2, keep the 1, use the 4 to round off. Is that 4 or less? By the way, there's a decimal point here. And the answer is yes. And so I'm going to drop all this. And the correct answer here is 2.21 times 10 to the 19th moles of HCl. Now, let's do another problem. And the question is, how many grams of ammonia, NH3, are 6.117 moles of ammonia, NH3? So the question is, what are you being asked to find, and what are you given? All right, my turn. What are you being asked to find? How many grams, and G is grams, of ammonia? what are you given? You have 6.117 moles of ammonia. So the only thing we have to start with is 6.117 moles of ammonia. And if we had a ratio to convert it, what answer do we want? Well, we figured that out here, grams of ammonia. And now it's your turn to figure out what units go on top and bottom of that ratio. Your turn. All right, my turn. And if we're going too quick, hit the pause button if you're watching this video. And when you're ready to see what the right answer I'll put in, you can start the video again. All right, how do we determine what goes on top and bottom of that ratio? Use your good buddy, your good friend, unit analysis. Whatever units we're trying to get to goes on top of the ratio. Whatever units we're trying to get rid of go underneath. Now, where do I get these numbers? Well, in case you forgot, what's the relationship between moles of a compound, ammonia is a compound, and grams of a compound? Well, if you look at important information, test a final exam, you'll see 1 mole of a compound equals the molecular weight of that compound in grams, and the molecular weight of that compound is the sum of all atomic weights. So now I need to find, first of all, the molecular weight of ammonia. And what is the molecular weight? As you saw, the molecular weight is the sum of all atomic weights. And for that, we need the periodic table, unless you got these memorized. And a number of them I do, but I don't expect you to. So ammonia has 1 nitrogen, the 3 significant figures. The atomic weight is 14.0. Hydrogen, over here, atomic weight 1.008. The 3 significant figures, that's 1.01. So I need the molecular weight of ammonia. And that's 1 nitrogen at 1 times 14.0. Now there are 3 hydrogens. And each hydrogen, there are 3 of them, is 1.01 atomic weight. Do the multiplication. It's the sum of all atomic weights, so I'll add it up. Now, when you're doing an addition, you get the same number of significant figures to the right of the decimal as the number that has the fewest significant figures to the right of the decimal. And in addition, all numbers, including 0, to the right of the decimal are significant. This is 1, this is 2, which is a smaller number, and time's up. Hopefully you pick 1. And therefore you keep the 0, here's our decimal point, and use the 3 to round off. That's 4 or less. So the correct molecular weight of ammonia is 17.0. So for every 1 mole of ammonia, there's 17.0 grams. And now if you notice, moles of ammonia divided by moles of ammonia cancel out, because anything divided by itself equals number 1, meaning it's gone. And now I can happily pick up a calculator. I am happy to have this It was interesting times before calculators. Yes, when I was in college, we didn't have calculators. We had slide rules. So turn on, clear it. I have 6.117 times 17.0. My calculator gives me this number. Let's start this again. Times 10 squared. Now, as you've learned all semester, all my tests, and the final will also say, please use proper significant figures for all calculated answers. And therefore, if we go back and look at this has 4 significant figures. This is an exact number. It's part of the definition. And this has 3 significant figures. And you get the same number of significant figures in a multiplication division as the number with the fewest significant figures. In this case, that would be 3. So I'm going to give you 6 seconds, 2 times 3, to round that number off the 3 significant figures. Go. I'm watching my clock. I'll give you a little extra time. Time's up. So to round this off, the 3 significant figures, keep the 1, keep the 0, keep the 3. Use this number 9 to round off. Is that 4 or less or 5 or higher? And 5 or higher. So I'm going to drop all this and increase that by 1. So my correct answer here is 1.04 times 10 squared grams of ammonia. And that's how you do that. And for those who came in late, we're going through review of important information on test 2. And if you notice, I have here, know how to convert, and we just did 2 of these 4, how to convert moles of an element to atoms of an element in the reverse, know how to convert moles of a compound to molecules of a compound, reverse, we just did that, know how to go from moles of an element to grams of an element and the reverse, and know how to go from moles of a compound to grams of a compound, which I just did, and the reverse. And if you haven't figured out by now, you should use your good friend, your good buddy, unit analysis. Now, one of the most powerful things I know in all chemistry is for a balanced chemical equation, like this, the coefficients, the number in front, give you molar ratios. And for this reaction, it tells me 2 moles of hydrogen. And when there's no coefficient, it's the number 1. React with 1 mole of oxygen to make 2 moles of water. This is one of the most powerful tools or concepts for me personally in all of chemistry. It allows me to write procedures, which I've done, to react chemicals to make a certain product, such as those used as fabric softener, antimicrobial compounds, and also as resins That's a fancy way of saying glue to hold sand together to make your car engine molds, to make your car engines and other things like that. And also to make plywood and things like that. So remember, the coefficients of a balanced chemical equation show you the molar ratios, and 2 moles of hydrogen, in this case, react with 1 mole of oxygen to give you 2 moles of water. Now, if you look on your screen, this is practice problems final exam. And how many grams of hydrogen, H2, are needed to react with an excess of chlorine gas, Cl2, to make 125 grams of HCl? And where it says hint, you're given a balanced chemical equation. And what are we being asked to find? Grams of hydrogen gas, H2. What are we given? Grams of HCl. There's no way I can go from grams of one compound to grams of another in one step. I'll say that in slow motion. There is no way I can go from grams of one compound to grams of another in one step. You can't. Well, you can try and you'll get 0 points. But anyways, how do you do that? You need 3 steps. Ooh, where do I find that? Well, if you look at important information, final exam, you see mass calculation. Let me move the ribbon up. Mass calculations for reactions. Mass means grams. And the first step is convert mass or grams of A to moles of A. Second step, and by the way, A is what you're given grams of. There'll only be one thing in my test problem. 2, you need second step, moles of A to moles of B. And finally, 3, third step, convert moles of B to mass of B. And I'd highly recommend you go back and look at these problems in chapter test. I think it's chapter 5, part 1, practice problems, but it's also here in the final exam. So step 1, grams of A, mass of A to moles of A. What's A? Hydrochloric acid, HCl. So we have the grams of HCl. We want to go to moles of HCl. Use your good buddy, your good friend, unit analysis. Whatever I'm trying to get to, the units go on top of this ratio. Whatever I'm trying to get rid of, the units go underneath. And where do I find a relationship between moles of a compound and grams of a compound? Important information, final exam. 1 mole of a compound equals the molecular weight of that compound in grams, and the molecular weight of that compound is the sum of all atomic weights. So we jump back to our problem. We have on top 1 mole equals the molecular weight of HCl. Well, we have to calculate the molecular weight. That's why these are 10-point problems. And there's 1 hydrogen, 1 chlorine. The molecular weight, the 3 significant figures for each of those elements found on your periodic table. You add it up, There's top one, 2 to the right of the decimal. Second one, 1 to the right of the decimal. Therefore, your answer should only have 1 to the right of the decimal. Drop the 1 because it's 4 or less. And the correct molecular weight of HCl, hydrochloric acid, 36.5. And grams cancel out. I'm left with moles. 3 significant figures, 3 significant figures, exact number, 3 significant figures. However, let me remind you, for a multiple part or step calculation, there's 2 philosophies. One, round off at each step, and that's what Dr. White has always done all my life, or round off at the end. I'm not going to force you to do one or the other. So I'll calculate it both ways, and you'll see in the bottom here what that means. But if you round off at this step, you get 3.42 moles of HCl. Second step, moles of A to moles of B. Well, moles of A is what we just calculated, HCl. Moles of B is what we're trying to get to the molecule in our answer. In that case is hydrogen gas, H2. So we have moles of HCl. We want to go to moles of H2, hydrogen gas. Use your good buddy, your good friend, unit analysis. Whatever you're trying to get to goes on top of the ratio, moles of hydrogen gas. Whatever we're trying to get rid of, we don't want HCl in our answer, moles of HCl. Where do I get these numbers? From the balanced chemical equation. The coefficients give you molar relationships. When there's no number, it's the number 1. And up here where it says hint, I like that, hint. Anyways, 1 mole of hydrogen reacts with 1 mole of chlorine gas to make 2 moles of HCl, hydrochloric acid. So for every 1 mole of hydrogen, we make 2 moles of HCl. These are exact numbers. 3 significant figure, exact number, 3 significant figures. And now we go to step 3. Step 3 is moles of B to grams of B. B is whatever molecule you're trying to get the answer for. In this case, it's hydrogen gas, H2. So we want to go from moles of H2 to grams of H2. Here's our moles of H2. I don't have down here, bad Dr. White. That should be a gram HCl, H2. And whatever we're trying to get to goes on top. And whatever we're trying to get rid of goes underneath. And where do we get this relationship between a molecule, a mole of a molecule, and grams of a molecule? Once again, important information, final exam. 1 mole of a compound equals the molecular weight of that compound, and the molecular weight of that compound is the sum of all atomic weights. And therefore, what's the molecular weight of hydrogen gas, H2? 2 hydrogens, each hydrogen is 1.01. Multiply that by 2, you get 2.02. Put that in there, moles cancel out, and that should be water. I'm going home. Wait, I am home. That's a mistake I made, too, in this problem, minor. That should be 1 mole on the bottom of H2, not H2O. I guess I had water on the brain when I wrote that. Ooh. Anyways, and the answer is 3.45, 3 significant, 3, 1. Your answer should have 3 significant figures. Now, if you notice, I have or 3.6. The or 3.6 is the answer you'd get if you waited until the very end to round it off to 3 significant figures. Now, if you notice here, I have some balanced chemical equations. Remember, I promised there's 1, maybe 2 balanced chemical equations on the final exam. Remember my advice to you. Leave hydrogen and oxygen till last. And you should have the same number of atoms of each type on either side of the arrow. And as I have here, remember the coefficients of a balanced chemical equation are molar ratios. All right, that ends test number 2 review. Any questions about any of that material? I'm all ears. Do you know that your ears are the one thing in your body that always keeps on growing? When I was younger, these are smaller. I see someone like my joke. All right, let me open up test number 3 review. Remember, all these reviews are in the lecture section of Blackboard. Thank you. Let me close a few things. All right, got all my straightening out. All right, now test number 3, we started talking about gases. An important measurement, physical property of gases is pressure. And you should know 760, and this should be millimeters. I have it correct elsewhere. Millimeters of mercury equals 760 millimeters of, oh, I do have that. So that should have been torr. 760 torr equals 760 millimeters of mercury equals 1 atmosphere. And as I've said all semester, in the past, students would have to memorize this, but this will be an important information test number or the final exam. And notice here on your screen, it is there. And I got it right. 760 torr, 760 millimeters mercury equal 1 atmosphere. So let's have a little practice. And I'm going to let you try this all on your own. Remember, 1 atmosphere equals 760 torr equal 760 millimeters of mercury. So I'll let you try this all on your own. And please be patient. I try and give everybody time to finish. All right, my turn. What are we being asked to find? Atmospheres. What are we given? Torr. The only thing I have to work with is this. What units do I want my answer to be in? Well, I figured that out. And now it's time to use my good buddy, my good friend, unit analysis. Whatever units I want to get to go on top of the ratio. Whatever units I'm trying to get rid of go underneath. And where do I get that relationship? Well, important information, which I also wrote on this page. 1 atmosphere is 760 torr. So now notice torr divided by torr will cancel out because anything divided by itself equals the number 1, cancels out. And now I'll clear my calculator. 851.2 divided by 760. And my calculator gives me 1.12 times 10 to the 0 ATM. And remember, you get the same number of significant figures in your answer as the number that has the fewest significant figures. And here, this is a tough one. I didn't realize that it was that tough, but you'll see what you have to do. This is 4 significant figures. This is an exact number. This is an exact number. So our answer has to be 4 significant figures. Well, it's only 3. What do we do? Well, when you're in scientific notation, 1.12, and to make it 4 significant figures, add a 0 times 10 to the 0, which is also just equal to 1.120 atmospheres. Now, next I talked about Boyle's law. Boyle's law is a relationship between pressure and volume of a gas. And Boyle's law is P1 times V1 equals P2 times V2. And P1 is the initial pressure, V2 is the initial V1 is the initial volume. P2 is the final pressure, V2 is the final volume. And I don't have one of those important practice problems final exam, so let's do the following. Checking to see you can see that. All right, let's look at problem number 6. If a balloon has a pressure of 658 torr and a volume of 1.894 liters, what is the pressure of the balloon if the volume is increased to 5.133 liters? Well, what are we trying to find? The final pressure, P2. The initial pressure, P1, is 658 torr. The initial volume, V1, is 1.894 liters. And as the volume is increased, meaning the final volume is 5.133 liters. And what do we see? We see only pressure and volume for a gas. Immediately, you know Boyle's law. P1 times V1 equals P2 times V2. Now, to get solve for P2, we have to get rid of V2. How do we do that? Divide. Anything divided by itself is number 1 times P2 would be P2. Whatever you do to one side, you have to do to the other. This cancels out. I have P1 times V1 over V2 equal P2. Now, I've just rewrote it this way. I now put in the numbers. Notice liters cancel out. I'm left with torr, which is a pressure, which we're trying to find. And this has 4 significant, 4, 3. My answer has 3. And with that, it's time to take a 5-minute break. I'm going to get up and stretch, and I'll see you in 5 minutes. I'm back. Let's get back to work. All right, we were talking about gases, and let's go back to important information, test number 3. Or to review actually. And the thing you should remember is the ideal gas law. The ideal gas law is PV equal nRT. P is pressure, but it has to be in atmospheres. V is volume. It has to be in liters. N is the number of moles. T is temperature, and it has to be in Kelvin. And important information on the final exam, I will give you Kelvin equals degrees C plus 273. And finally, R is the universal gas law constant, which is equal to 0.0821 atmospheres, liters, mole K. That's 3 significant figures because that's a calculated number. And if you look on the screen, you'll see problem 15 from practice problem final exam. What is the volume of a tire that contains 24.0 grams of nitrogen at 101 degrees C at 745 torque? Now, what are you being asked to find? Volume. What are you given? The weight of nitrogen, the temperature of that nitrogen gas is N2, the pressure of the nitrogen gas, and you'll see an important information, final exam, you're given R, 0.0821 atmospheres liter mole K. Now, if you look at this problem, are any of the variables changing or measurements? No. You're being asked to find a volume and nothing changes. And 15 points. And therefore, it's PV equal nRT, the ideal gas law. We want to solve for V, volume, to get rid of the pressure P. We, first of all, just RC, no. We divide this side by P. Because anything divided by itself becomes number 1, it's gone. I like that. It's gone. But anyways, whatever you do to one side, you have to do to the other. And I did. And P divided by P is 1 times V is V. And this side is nRT divided by P. Now, what's N? N is the number of moles. Oh, no, you're given grams. So how do we convert grams of nitrogen to moles of nitrogen? Use your good buddy, your good friend, unit analysis. Whatever we're trying to get to goes on top of the ratio. Whatever we're trying to get rid of goes underneath. Where do we find a relationship between mole of a compound and grams of a compound? Important information, final exam. 1 mole of a compound equals the molecular weight of that compound in grams, and the molecular weight of that compound is the sum of all atomic weights. So, to get moles of nitrogen, 1 mole equals the molecular weight of N2 nitrogen gas. The molecular weight, 2 nitrogen, N2, 2 times 14.0. Where did I get that 14.0? The atomic weight of nitrogen is 14.007, but the 3 significant figures is 14.0. And that's 28.0, 2 times 14.0. So for every 1 mole of nitrogen, there's 28.0 0 grams of nitrogen. And therefore, exact number three significant figures. Since you're doing multiple calculations, there's 2 ways of rounding off. One at each step, which I'm at each step round off person, or at the very end. And I calculate both. But for this problem, what you see right now, I'm rounding off at each step. Now, volume equal nRT divided by P. N is the number of moles. We have that. R is the universal gas law constant. You'll find that. Let's just make sure I'm not lying to you. Important information, final exam. I wasn't lying to you. It's right there. See, Dr. White can be sarcastic even the last week of class. Next, we need temperature, but temperature has to be in Kelvin. You look at important information, a final exam, it tells you that. And Kelvin, temperature in Kelvin equals degrees C, which is what we're starting with, plus 273. That was 101 plus 273 is 374 Kelvin. And finally, we have to find the pressure, and that has to be in atmospheres. And just to remind you, you look at important information, final exam, pressure has to be in atmospheres. And we just did one of those problems. Well, let's do it again. We have 745 torr. We're trying to get the atmospheres. Atmospheres go on top of the ratio, torr go underneath. Where do we get that number? 1 atmosphere equals 760 torr, which is also an important information test final exam. I keep on wanting to say test. Boy, did the summer go quick. So 1 atmosphere is 760. This is an exact number, 1, 760 exact number, but the torr here for 745, 3 significant figures. My answer is 3 significant figures. So now we have N, which I put here for N, R, temperature in Kelvin right here, and the pressure in atmospheres right here. And this is 3, 3, 3, and 3. And that's 26.9 liters, or 2.69 times 10 to the first. Or if you round off at the end, not at each step, that's 26.8 liters. Now, let me remind you, in the winter, it gets cold. Temperature goes way down, like here in Chicagoland. This winter wasn't that bad like it has been in the past. I think it's global warming, but anyways, what equation tells you when to check your tires? Well, that equation is PV equal nRT. And in your tires, the volume, the moles, and R are all constant, unless you have a flat. Those aren't fun. I've had a few, they're never fun. So therefore, if the temperature goes down, the only thing that can change on the left, the pressure will go down. And in the summer, we didn't have two, luckily here in Chicagoland. I better keep keep my mouth shut, but the temperature, I feel sorry for those people in Phoenix. Today was the first day in the last 32 days that the temperature, daytime temperature, didn't go above 110. It was only 107. Ooh, it's getting cooler there. But anyways, in the summer, temperature goes way up, and PV equal nRT tells you V, N, and R are constant in your tire. And if the temperature goes down, wrong season. The temperature goes up, then the pressure will go up. And back in, I think it was the summer of 95, when it was so awful because it got so hot here. That was before we had cooling centers. Over almost 600 people in Chicagoland died from the heat related problems. When I was driving to work on the toll roads, you could see in the afternoon cars and trucks pull over with blowouts because the heat caused the tires to expand like balloons and pop. That's what's a blowout. All right, let's continue on. Test 3 review. I talked about Dalton's law of partial pressures. The total pressure of a mixture of gases is the sum of the partial pressures of the gases. One thing, time out. Remember, the best way to prepare for the final exam is to look at your hourly exams and use those as practice problems. The best way to prepare for the final exam is to look at your hourly exams and use those as practice problems. You can do those, you're in good shape to do well on the final, which I hope everybody does. Now, don't forget, when it comes to boiling, that's when a liquid becomes a gas. The boiling point of a liquid is the vapor pressure. When the vapor pressure, and I'll never ask this on a final, of a liquid equals the atmospheric pressure. But I did ask the next thing on test number 3, and I could ask on the final, and that is the higher the altitude on the earth you go, higher up in the mountains, the lower the atmospheric pressure. And because of that, you need less energy to make the vapor pressure of a liquid you're heating equal atmospheric, meaning boil. Therefore, the boiling point is lower. Next, I talked about solutions. And a solution, we talk about the solvent, the component of a solution present in the greatest amount, and the solute, all other components in a solution. Now, a solution, things are dissolved, but something that you might think is a solution, but it's not, is a colloidal dispersion. Those are particles suspended in a liquid, and not a solution. And my flashlight, one of my favorite ones, if it's a solution, the light goes through. If it's a colloidal dispersion, my hand does not, but no light goes through. Actually, some of it's starting to come through. These are powerful flashlights, and expensive too. They're custom made from this gentleman in China, Hank Wang. What a great craftsman he is. Anyways, next I talked about like dissolved light. Things that are polar are soluble in polar things, solvents, and nonpolar solutes are soluble in nonpolar solvents. Things that are polar are water, salt, and alcohol. Things that are non-polar are vegetable oil, gasoline, Vaseline, otherwise known as petroleum jelly, and baby oil. And later on, you also learn dirt. And if you mix something polar with non-polar, you'll get a heterogeneous solution. They're not soluble. Now, we talk about the solubility of a solute. That's the maximum amount of a solute that will dissolve in a given amount of solvent. Saturated solution, a solution that contains the maximum amount of solute that can be dissolved under the conditions at which the solution exists. Dilute solution, a solution that contains a small amount of solute relative to the amount that could dissolve. Concentrated solution, a solution that contains a large amount of solute relative to the amount that you could dissolve. And aqueous solution, remember that's abbreviated by bracket AQ close bracket. That's where water, that's H2O, I hope you all know that, is the solvent. Now, to make solutions concentration, I've only asked you to know molarity. Molarity of a solution is the given ratio of the number of moles of solute per 1 liter of solution. Now, molarity, which is designated by capital M, is moles of solute per 1 liter of solution. Well, 1 liter equals 1,000 milliliters, so you can also write it as moles of solute per 1,000 milliliters of solution. If you go back to test number 3, you see I asked you, what does this mean? And afterward, I had bracket AQ close bracket, and what is the solvent? And it was water. Now, if we look at problem 13, or let's look at problem 12 in important information or practice problems final exam. What does 4.56 capital M NaBr mean? And that means capital M molarity. And that tells you 4.56 moles of sodium bromide NaBr per 1,000 milliliters. Now, if there had been after the Br bracket AQ close bracket, that would also mean the solvent is water. Now, let's look at number 13. How many moles of sodium fluoride are in 512 milliliters of a 1.45 capital M NaF solution? Now, what are we being asked to find? Moles of NaF. What are we given? A volume and this number, 1.45 capital M NaF. What does that mean? Capital M with a number in front and a formula afterward tells you molarity, which means it's 1.45 moles of sodium fluoride per 1,000 milliliters. Now, the only number we really have to start with is 512 milliliters. We're trying to get the moles of sodium fluoride. And it's time to use, ta-da, your good buddy, your good friend, unit analysis. whatever we're trying to get to, the units go on top of this ratio. Moles of sodium fluoride. Whatever we're trying to get rid of, the milliliters goes underneath. And where do we get a relationship between moles of NaF and milliliters? From the molarity. 1.45 moles of sodium fluoride per 1,000 milliliters. And milliliters divided by millimeters cancel out. Do the math. Remember, this is 3 significant. 3, the 1,000 is an exact number. Therefore, my answer has 3 significant figures. Now, let's look at number 14. This is a very important problem. Hint, this is a very important problem. Double hint. And that is how many grams of sodium chloride are needed to make 341 milliliters of a 9.77 molar, that's what the capital M means, sodium chloride solution. So we're trying to get grams of sodium chloride. We're given a volume, 341 milliliters, and we're given the molarity. And the molarity is capital M, tells you molarity, is 9.77 moles of sodium chloride per 1,000 milliliters. But there's no way you can go directly from milliliters to grams. No way. You need 2 steps. And what if you don't remember the 2 steps? Well, you look at important information somewhere here. There it is. Important information, final exam. And the molarity 2-step problems. And that's step 1, you go milliliters to moles. Step 2, moles to grams. So let's do that. So first step, we go milliliters to moles. Milliliters of what? NaCl to moles of NaCl. We have these many milliliters. We want to get the moles of NaCl. We have a ratio that will convert it. And what goes on top of the ratio? Whatever units you're trying to get to. Moles of NaCl. What goes underneath? Milliliters. And where do we get the numbers here? From the molarity. 9.77 moles of sodium chloride per 1,000 milliliters. And I put it in there. 3 significant, 3 exact number, 3 significant figures. But once again, this is a multiple step calculation. Time out for a water break. And this you can round off at each step, and I'm going to round off at each step person, or you can round off at the end. Now, I calculate both ways on a test or the final, so you can do either way, but I'm going to round off at each step person. So I did. So I have 3.33 moles of sodium chloride. Are we done? No, we're trying to get the grams of sodium chloride. And the second step is moles to grams. In this case, is sodium chloride. And you have 3.33 moles of sodium chloride. You're trying to go to grams of sodium chloride. Whatever we're trying to get to goes on top of the ratio. Whatever we're trying to get rid of goes underneath the ratio. And where do I get this relationship of a mole of a compound to a grams of a compound? Important information, final exam. 1 mole of a compound equals the molecular weight of that compound in grams, and the molecular weight of that compound is the sum of all atomic weights. So for every 1 mole, I need the molecular weight of sodium chloride. Well, sodium chloride molecular weight, MW is shorthand for molecular weight or abbreviation, not really shorthand. And 1 sodium, 1 chlorine. Remember, you go to the periodic table. Oops, hold on. And you look at the atomic weights underneath. And for my class, it will say under the final exam, just like test 2, 3, and 4, use all atomic weights to 3 significant figures. 1, 2, 3. Ooh, I got it right. And here, 29.989, the 3 significant figures, 23.0. For chlorine, 35.54. Let me say that again, 35.453. The 3 significant figures is 35.5. And if I add those two up, I get the molecular weight. Of sodium chloride, 58.5. You both have 1 past the decimal, so my answer has 1 past the decimal. And I do the math, 3 significant, 3 exact number, and I get 3 significant figures. Now I have 195. That'd also be 1.95 times 10 squared. 195 is 1.95 squared. All right. Now, if I look at the clock, we're doing pretty good. So I think it's time for a Dr. White story. Now, you've learned organic chemistry, and I figured this is a personal story. Important molecule. These are called quaternary ammonium salts. And if you work in the industry like I have, and you're a world expert in this type of molecule, which I am, you call them quats for short. But when I teach, I try not to use slang. Now, quaternary ammonium salts, one of the most important areas, are fabric softeners. And company I worked for, and I was in charge of all research for this area of North America. And our 2 biggest customers were Procter & Gamble, P&G, and Unilever. Back then it was called Lever Brothers. And the 2 main brands are Downy and Snuggle. Now, we sold half of what they needed every year in the United States. If you're in a company and you have a certain chemical you need for a big product, you always make sure you can get it from 2 different companies. So if one company has a problem, you can go to the other to get more, and you're not just shut out. But anyways, we were the major supplier of the quaternary ammonium salt to Procter & Gamble. And one day I get a call from the vice president of marketing and sales. We've got a problem. So what do you mean we got a problem? Who's with? Procter & Gamble. What do you mean? Well, our quaternary ammonium salt, which is called trade name Arquad 2HT75, they came up with a new formulation for Downy, and now our quaternary ammonium salt product makes that makes that product stink. I said, what? Well, it does. They're not going to buy from us if we don't fix it. So because it was such a multi-million-dollar account, I mean, lots of money. I mean, lots and lots and lots of money. All of a sudden, the next day, when I got in my office, the president of the United States of our company called me. Did you solve it yet? And at noon, he'd call me. Did you solve it yet? And before I went home, he'd catch me and call me. Did you solve it? I was getting calls a couple times a day. That wasn't fun, especially when I had to say no. Well, this went on for about 2, 3 weeks. We set up an odor smelling panel and tried different things, and we couldn't tell anything. And at that point, I realized I was spinning my wheels. I couldn't solve the problem. Something was wrong with the information I was given, because I should have solved the problem. So I called up our vice president of marketing and sales and said, you got to have the salesman for P&G go in and set up a meeting with me and someone there to find out what's the exact problem. Well, it turned out that was a challenging thing. Why? Because at that time, I don't know about now, Procter & Gamble for the whole company had 5 senior perfumers for different areas, market segments. And their job was with their nose, whatever certain products smelled like yesterday will smell the same way today and will say it smelled the same way tomorrow. And that's really tough, because even today they don't have good analytical instruments as good as a person's nose. Well, these 5 individuals were treated like gods, because if you're in Procter & Gamble and you're selling to housewives and a product they bought last month, they buy, smells different. There's something wrong with it. I want my money back. So they better make sure they get it right. And these guys had the noses that were that sensitive that they could tell that. And they were treated like gods. How did I know that? Because first of all, they wouldn't let me meet with this guy. And I said, you want us to solve the problem? I need to talk to the person who's saying it stinks. And finally, I got a call from a senior vice president at Procter & Gamble and said, we'll let you come in a meeting, but listen carefully. One, and unfortunately at the time I did smoke, you can't smoke for 24 hours before you meet with this guy. 2, you better treat him politely, because if you get him upset, we will cancel our business with your company. Ooh. And at that time, for a number of years, my counterpart in their research and development at Procter & Gamble, a really nice gentleman, Earl, I won't give you his last name, but I still remember it. I said, can Earl be in the meeting? And the vice president of P&G, no. I said, wait a second, he's in your own company. Well, we keep these people protected. And I said, well, he needs to really be in there. So finally, this senior vice president said, all right, he can be in the meeting too. And this is their own person, a senior research manager. So we had a meeting. I had the marketing vice president of marketing and sales, or no, the marketing sales manager came with me. I was there. On the other side of the table was this gentleman, I can't remember his name, a really nice gentleman, taught me a lot, who's their senior perfumer for this area for fabric softeners and other type of household goods. Earl was there, and that senior vice president. And really it was the meeting between me and this one senior perfumer. The rest were there for keeping an eye on things, whatever. And I asked him, I said, I have been told our quaternary ammonium salt makes your new formulation stink. Is that correct? He said, no. I said, well, what is correct? He said, and this is amazing. He said, with the new formulation, your product, the intensity of our new perfume, and that's what was the new formulation, a different perfume, they decided to change to something better. And it was, the intensity of perfume was less than your competitor's quaternary ammonium salt. I said, oh, now I know how to sell for it. And we had talked some more things, and I still remember, this was decades ago. He said, you know, yesterday I smelled something really strong and it blew out my nose. I should have gone home. Nobody laughed, because he was being very serious. And it was just interesting things he taught me about how to test for smelling and all that. And I won't go into it, how to set up a test panel. And immediately I went back, and don't tell anybody, but chemical companies know how to get samples of their competitors, at least the company I worked for did. we got a sample of our competitors. We had our quaternary ammonium salt. And at that time, our analytical department, I ran research, but we had an analytical department. And the head of that was, and I still remember his name, great fellow, I hope he's still alive, Dr. Chunan Wang, was amazing analytical chemist. I just went, hey, Chunan, here's our product, here's there's something different in there. We got to find it out. Help me. And he helped me identify what was the difference. And it was a minor difference, but it was enough to make the perfume smell less intense. And I figured out how, when we make that quaternary ammonium salt, this impurity, to reduce it. Why reduce it to zero? And I talked at this time now, they let me call the perfumer. I was really honored to do that, seriously. And the perfumer said, oh, that new sample is no good. What's wrong? Well, now the perfume is too strong. So I knew what the impurity was, and I knew how to adjust the level. So we adjusted it to the same as our competitors and sent them a sample. They made their formulation. They said, perfect. And I stopped getting calls from the president. He thanked me. I got a good raise too, because it was a hard problem to solve, and I did solve it. But that was an interesting story. Now, if I have time, I'll do one more story. But first, having worked with both Procter & Gamble and Unilever, when you're using a fabric softener, which I do, the best way is the fabric sheets. The fabric sheets are much better than the pour in your washing machine, the liquid fabric softener. You get more quaternary ammonium salt on your clothes, so it does a better job softening. So use the sheets, not the liquid. It's better. Now, along that time, I was working for the same company, and a company that supplied us product, we had problems with their product, and that caused me problems because I'd have to go to our plant and figure out what went wrong, and oh, they sent us garbage again. So I called up this company. I said, can I talk to some people in your production? I went and met with them. They were on the south side of Chicago, the plant we bought from. I said, you got to do this, and that will stop the problem we're having. And they thanked me. Well, a couple of months later, their research director, who was also in charge of quality control for all North America, was retiring. And I'd so impressed that company, they called me up and said, we've got a job for you. And I said, I'm happy where I am. And they made me an offer I couldn't refuse. They doubled my salary. Yep, doubled it. And I went there. And now I was working for a Unilever company. And when I was at a meeting in England, by the way, chemists party hard, especially on company money. And we had this big meeting, and at night, each night, we'd go to a local pub and have a good time on company money. And I didn't say that, but we did. And second night, because I was a senior manager, that's what this meeting was for. The vice president of research development for all Unilever was there. And one of my colleagues there said, why don't you go over and ask him about the snuggle bear? And this guy thought I'd be too scared to ask him. Nah, he breathes just like I do. So I'm not afraid to talk to anybody. I've worked with CEOs at that point of big companies I was employed with. And so I went over and we introduced him. Oh, I've heard about you. And we talked. I said, I was asked by someone to ask you about the snuggle bear that you know about. And he laughed and he said, well, I guess you need to know the story. I said, well, I guess we want to share it. If you look on your screen, You see Snuggle with the cute little teddy bear on there. And the story to Vice President of Research Development, very powerful, important man in the company, told me was when they came up with Snuggle, the product, the marketing needed some kind of mascot or some symbol to put with this new product. And they had, I don't know how much money, a contest through all of Unilever that if you come up with a mascot or some sort of symbol or whatever we use for the product, you'll get a nice sum of money. And I don't know how many thousands of dollars it was. Well, the story tells was one morning he's going to work, goes to kiss his 5-year-old son, who's holding this teddy bear that's sort of beat up. And the guy said, "That's it." And he asked son, "Can I borrow your teddy bear?" No. Well, it took him a couple of days. I don't know. He never told me what he promised. I'll give it back to you, but can I borrow it? He promised something nice to his son, brought it into the marketing department. Here's your mascot. And that's how the teddy bear got on Snuggle. Now, if I look at the clock, we're going to end a little earlier because we've done enough today. Tomorrow's our last day. Boy, does summer go quick, the summer semester. Now, listen carefully. Don't forget, tonight at right before midnight is the deadline to hand in everything. Don't forget, on Thursday, we will have no lecture, but you'll have all day Thursday, and by Friday, 2 p.m., this is a hard deadline. You have to get your answers in for the final exam. Anybody getting it in after 2 p.m. gets a 0 for the final exam. And with that, I'm done for today, but I'll remind you if you have any last-minute questions, I will have my last office hour of the semester tomorrow, Wednesday, from 7 to 8 p.m. So ask questions. Stop by, say hello. Also, finally, if you like what I did this semester, and a lot of you just see me through my videos, but if that helped you learn chemistry, please go to ratemyprofessor.com and put something nice down. And if you really like what I did, look in Blackboard. Let's go there. You'll see over here on the left says important email addresses. If you click on here, you'll see two files, one PDF, one a Word document. I'll click on this one, and you'll see the email for Dr. Caputo, President of COD, and the email address for the Board of Trustees. If you really, really liked what I did this semester, send Dr. Caputo a letter, an email letting him know, and copy the Board of Trustees. And with that, I'm done for today. I'll see you tomorrow, our last lecture. Gang gesund. You're welcome. I'll see you tomorrow.